Okay, in this video we're going to talk about amphiprotic substances. So these are substances that can act as acids or act as bases. Our most common example here is water. And water, for example, if it's exposed to an acid, will accept the proton from the acid to form hydronium. And if it's acting as a base, or if it's exposed to a base, can act as an acid, donating its proton. So here it's a base, and here it's an acid. So we can see that it can behave as an acid or a base, and it depends on the solution that it's in. It depends if it's with an acid, it acts as a base, and if it's with a base, it acts as an acid. That's kind of interesting, but it's not the only solution, and it's kind of the obvious example. So let's look at something else that can act as an acid or a base depending on its situation. It's a little more interesting. Let's look at baking soda or sodium bicarbonate, NaHCO3 plus HCO3. Now, if this is put into water, it will dissociate. The sodium ions, which are the conjugate of the strong base NaOH, basically don't participate in any further acid-base interaction. You can think of the sodium as basically something that lets us get bicarbonate into solution, but then really doesn't have any role in this. And then our bicarbonate, which is carbonate with just one hydrogen, is the interesting substance here. Bicarbonate can act as an acid or a base depending on whether it's put with an acid or base. So for example, if HCl is reacted with bicarbonate, because HCl is an acid, the bicarbonate will behave as a base. That means that the proton will be donated from the HCl to the HCO3, making H2CO3 and Cl-. In this way, the HCl is actually neutralized by the HCO3, and putting the HCO3 in this situation will actually raise the pH of the water or make it less acidic. H2CO3 itself will act as an acid, but it's a weak acid, and so it won't donate as many of those protons to water to form hydronium as the HCl would have. So in this case, the HCO3 is behaving as a base. Alternatively, if we react HCO3 with a base, let's say NaOH, here the Na is going to split off and just hang out on its own. The H from the HCO3 will go and meet up with the OH and form H2O, and then we'll be left with the carbonate anion. In this case, because the HCO3 is donating its proton, we call that an acid, and the OH that's receiving is acting as a base. So what we can see then is that HCO3 can act as an acid if it's placed with a base, or a base if it's placed with an acid. I'm just going to pause here. I'm going to cut this video, and then I'm going to come back and I'm going to look at what happens then if we titrate sodium bicarbonate with an acid and a base, and we'll see that we end up with two different equivalent points.